Hello, everyone, and welcome to our What's New in SAP HANA Cloud webinar. It's actually the first time in 2023 that we can share an update on some exciting innovations that we will be introducing into SAP HANA Cloud very soon with our quarter 1 release of the product. So I'm super excited to give you a glimpse into some of the great things ahead of us. But before we jump right into the content, let me highlight today's speakers, as I'm, as usual, not just on my own. And we have, as you can see already by the speakers, quite some topics to cover. Basically, a whole lot of innovations that are just waiting to be released to SAP HANA Cloud with our Q1 release. As always, we unfortunately can only cover a limited scope of the innovations and the new enhancements that we will be introducing. So we have selected our highlights for specifically this session today. But for sure, there's more part of the release. And if you want to get more insights into what's part of SAP HANA Cloud, apart from the innovations here listed on the screen, and apart from those that we will dive in detail into the session today, you can always have a look at our What's New viewer, because there we will give the most precise insights into the entire release scope. And we will also be releasing with our release as such, basically also a What's New blog, which tries to go into more details and also give some insights into topics which didn't make it into today's webinar just because of the time limitations. But now, basically, without a lot of further ado, let me hand over to Ritti, who will basically guide us through the first set of innovations that will be introduced specifically in the area of infrastructure updates. So as you can see on the slide, we will start with the SAP HANA database first. We will then take a look at the administration tooling, which is relevant for HANA Cloud as a whole. Later on, we will dive into specific innovations for the data lake, and then we will give also some more general updates and conclude the webinar. So as that, Ritti, the stage is basically prepared for you, jumping right into the topic of infrastructure updates with SAP HANA Cloud.
All right, so so once again, I'm Ritti Joseph, and I'm pleased to have the opportunity to highlight some of the recent new features in the HANA database infrastructure. So with the new flexible database configuration feature, we are going to add support for different performance classes and for the SAP HANA database instances. But before we go into this topic, let me talk about what we offer today. So currently, the HANA instances has a fixed CPU core to memory ratio of 1 vCPU to 15 GB of memory, and 1 vCPU to 16 GB of memory ratio, depending on the landscape that one is on. And in addition to this, there is also a high memory exception provided in certain landscapes. So as you can imagine, this restriction is hard for total cost of ownership optimized instances. And for example, if your instance requires more compute but fewer memory blocks, then there's no option but to pay for more redundant memory blocks. And this excess capacity increases the total cost of ownership, and it also negatively impacts the sustainability of the solution. So in order to mitigate this, we are going to add support for different performance classes for the SAP HANA database instances. And we will gain more freedom to choose a core to memory configuration that is best suited for your specific workloads. And we do this by allocating either more memory or more processing power to your instance. And by doing so, you also ensure to have the right amount of resources and at hand while also maintaining reasonable cost. So the different performance classes or core to memory ratio that will be available are, as you can see on the right-hand side of my screen. That is the high compute, which has the core to memory ratio offering of 1 vCPU to 4 GB memory. And this is optimized to support compute-intensive workloads that require fewer memory resources. Similarly, we have the compute, which has a core to memory ratio of 1 vCPU to 8 GB of memory, and this is optimized to support compute-intensive workloads again. So Yeah, before I talk about the memory and the high memory ratios, so these ratios are actually limited to a memory range since it depends on the machine types which are offered by the hyperscalers or the cloud service providers. So there is no homogeneous offering across all of them, but however, we provide options that give you the flexibility to choose between a common set of ratios and sizes, which will be best suited for your workloads. So coming back to the memory or the default offering, this has a core to memory ratio ranging from 1 vCPU to 13 to 16 gigabyte of memory. And this, as I said, is the default compute memory ratio, and it is also suitable for most of the workloads. And finally, we have the high memory core to memory, high memory performance class, and a core to memory ratio of 1 vCPU to 20 to 30 gigabyte of memory. And this is ideally optimized to support processing of large data sets that require a lot of memory. And this range of core to memory ratios, it provides the flexibility to upgrade systems in the future as the needs change, which is especially important in businesses that are growing and evolving. So here you can see the illustration of the minimum and maximum memory and CPU ranges per hyperscaler. So for instance, the AWS landscape, in the AWS landscape, you can see the high compute, which is the 1 to 4 core to memory ratio. It has a minimum and maximum vCPU range of 8 to 90 CPUs and a memory range of 32 to 360 GB, which fulfills the 1 to 4 high compute ratio. And similarly, we can see this for all the other performance classes and in each of the hyperscalers and yeah, like Azure and Google. So as you can see here, within the multi-environment HANA Cloud Central, you will now easily be able to change the configuration of your instance and choose a performance class, which is either the memory, the high memory, the compute, or high compute. And you can also change the memory size. And as you can see here, and this will also reflect the compute associated with it, and which thereby also fulfills the core to memory ratio. This is definitely a great improvement to you as there are no delays anymore, and you can directly interact and change the configuration of your database system as you require it on demand. But yeah, also please note that the available memory range will vary by the performance class and also the landscape that one is on. So for example, if the maximum memory of the high compute and the compute will be different, and it will also differ in different landscapes. Similarly, you will also be able to change the configuration of your instance and choose the performance class that is best suited for your needs from the HANA Cloud, Cloud Foundry, HANA Cloud Central tooling. However, this can only be done for memory and high memory performance classes, and you will not be able to choose between compute and high compute from this tooling. And with that, I am done with the updates for the infrastructure bit, and I will hand it over to you, Christoph. Thank you.
Thank you very much, Riti. I just start over with the updates in the area of HANA machine learning. Yeah. Okay, so we have again a series of new functions and updated capabilities as part of the predictive analysis library in the machine learning area in this HANA Cloud release. So one of the first enhancements here I'd like to mention are enhancements to the AutoML and pipeline capabilities, where there are new operators, like, for example, feature generation operator to, based on existing numerical feature, it allows to generate new insights as kind of new features can be generated from numeric features relevant for some of the algorithms you would be using as part of the AutoML project. But even more exciting is that we now support explainability across pipeline models and AutoML models, where basically if you have a predictive model which uses multiple PAL algorithms or operators in a sequence, you are now able to explain how the predicted values derive and map to the input data you have passed into the predict function using such a pipeline or AutoML model. So there's a new SQL function called pipeline explain. It's similar to the actual pipeline predict function, but it gives you the additional insights using the reason code explained explanations for the predicted values. Then there's another enhancement in the AutoML engine called successive halving, which provides even faster results using fewer resources during the pipeline optimization. So if your AutoML project would have, for example, trained 100 different pipelines using this successive halving approach, maybe you would be even faster, only training 50 or 60 pipelines, as the optimization through the space of combinations is faster using fewer resources. There's also, for some operators, the option to customize the pipeline output, as for example, where you derive new columns using principal component analysis, and you don't know yet how many output columns your project will have. This is now also supported with this customizable pipeline approach. In the area of time series functions, we now support online Bayesian change point detection, a new change point detection algorithm, which is typically used in two scenarios. One is you have a forecasting project and you'd like to know how many change points do I have in my time series. And then specifically for scenarios where you're getting in a signal of data continuously updated, maybe you load new data every minute, every hour, and then this online Bayesian change point detection algorithm can basically take the current model, add the data, and then detect if the new signal data indicates a change point in the data it has been seeing over time in the past. Then for scenarios where you have a large number of time series, for example, segmented time series forecasting, you often want to group similar time series together, and a new method, trending method called Rocket, is now available for more efficient time series classification. Under the miscellaneous enhancements, there's one new pre-processing algorithm, also very popular and standard, the power transform, which kind of stabilizes the variance in your data across the value ranges you may have for your features. And then there are some enhancements to the clustering algorithm and the unified regression algorithm supporting prediction intervals. For the machine learning clients, we basically have enhancements specifically in the Python machine learning client for data scientists, leveraging all the machine learning capabilities. One core area of enhancement we'd like to mention here are the model reports. The classification and regression report has been enhanced more towards a tab-based structure. We'll see that also in a second in the demo. And then completely new is the time series report supporting insight and analysis of time series in the beginning as you explore the time series, as well as you inspect the time series forecasting model and outcome. And that also includes the report for AutoML time series. Then in the area of SQL generation and artifact generation, if you'd like to operationalize what you as a data scientist maybe have created using Python, there's a new SQL table user-defined function generation capability, and also the ABAP managed database procedure generation now supports to generate pipeline models if you have been using the AutoML feature, for example, before. A new data importer for data lake storages, including the HANA Cloud data lake, is available for faster CSV import directly from the data lakes. And then there are some enhancements on individual functions like the linear regression algorithm, which now supports prediction and confidence intervals. So, but now let's have a look at the actual kind of capabilities in a demo. The first one is here in the Database Explorer, where I'd like to show the pipeline explain function. First of all, if we imagine we have trained an AutoML model, then like we can see here as the result one, the AutoML fitting would provide us with 2 or more candidate pipelines we would be using. The first one with the ID 0 is typically the best one. And we would then, in the next step, as we, for example, would be fitting the model or fine-tuning the model using the pipeline fit functions. That's typically something we can do. We would be adding new parameters called background size, which basically collects and samples some data from the actual input data, which is needed for the explainability, so that the values provided in for the predict data can be mapped to the original values of the different features used during training, and thus the explainability can actually happen across the complete pipeline. So as we then see, using the pipeline explain function, which is then configured using the top K attribution, that's our parameter for the predict functions, enabling the so-called reason codes. And as the reason code, we basically then with the predict output not only have the actual classification and the confidence of the classification, the prediction output, we additionally have the so-called reason code, where we basically, for each feature, we then have the percentage it influenced the respective predicted decision, or a typical approach in explainability applying machine learning. Now for the data scientist, if we look at our Python machine learning client here, I'm connected against a HANA Cloud system using some data. It's a classification example I'm using here. The first thing I wanted to show, I'm creating a Python pipeline object, and by using enable HANA execution, I'm actually building a pipeline for execution in HANA. I can then, for example, execute or refit this pipeline. So that was just a preparation step for what I actually wanted to do. I have now a pipeline. I've trained or fitted the pipeline. And for the same object, I'm also now executing the predict or instantiating the predict capability of my pipeline object. And I can now use the new function, create, apply function, give it a name which I want, and apply it on a given data set. And then basically the SQL statement is created, which basically creates the table user-defined function behind the scenes, which I can then apply using a select statement, passing in the table here as a parameter. We can see the actual statement, how it would be executed, and then execute it and inspect the result. Then looking at the unified reports, Same here. I've trained a forecast model using the PAL profit function called additive model forecasting, and then initializing or running this unified report, I would get all the insights on the actual data used for training. The forecast here, I would get all the information about the stationary component of the forecast, the autocorrelation, all that can be seen, rolling mean, what seasonality has been detected, etc., etc. All the insights can be generated and reported during the report and inspected during the report. And here I have another example using an ARIMA forecast where I also have external features included in the forecasting model. And just to highlight the explainability component of the external feature, here I can then also see how these external features actually contribute to the forecasted value using the model. And with that, I'd like to hand it over to the next speaker.
Thanks, Christoph, and hello to everybody. I will talk about the new features in HANA calculation views. And the first one that I want to talk about is that we allow now user-defined functions in expressions and calculated columns. That means now if you define an expression or in a calculated column an expression, not just in a filter, but also in a calculated column, then you can call their user-defined functions. Where can you use it? For example, if you want to pre-process an input parameter, for example, you want to map input values to different values by using a mapping table or anything like that. So you have the option to use logic encoded in user-defined functions to pre-process before you use it in your filter or calculated column. This also gives you another benefit, that you can reuse the logic, because if you create a user-defined function and you put a little bit more complex logic in it, you can use it in your other calculation views again and also share it across containers so that you don't have to reinvent the wheel again and again. And you also harmonize basically with that then how you pre-process certain values. Now, the next feature that I want to talk about is the attribute aggregation information. And this is something that deals with the fact that some calculations, like if you do averaging, depend on the granularity at which you do the averaging. So for example, if you calculate an average across all days, it's different compared to if you calculate an average across a month first and then across all months on top, because then you have a different weighting of the individual days. Now, because there's a difference in the outcome, it's important what the query is asking for, whether it's asking just for year in the group by or for year and month. Now we offer the option to define what you expect the query to ask for. So if you go to a calculated column or to a measure in general, you have now the option to specify that you expect the aggregation attributes like year and month in this example here. This information then is stored in the metadata. The view is called BMC exception aggregation attribute view. And if a client evaluates this information, then the client can send adapted queries to the calculation view. So by specifying these attributes here, you don't change the processing of the calculation view itself, but what you change is that you add some additional information which a client can then evaluate and knows how to formulate the query so that it's in line with what is expected from the modeling side. Then in the mapping pane, we allow now also to change the sequence of the individual columns. Before, the sequence was fixed, and now you can, for example, match it to your individual preferences, which can make it easier to map certain columns and probably also gives a better insight than if it fits to what your expectation about the sequence. You can select multiple columns at the same time and then move them up or down, depending on your preferences. For data preview, we added a rather small enhancement, but I think this was something that was requested by many customers. So even if it's a small enhancement, I think it will benefit a lot. Here in the past, if you had a table display, you could only, you were required to have a value on the value axis. Sometimes this was not wanted, and you just wanted to have already a display by just using the attributes values here. And this is now possible. If you only add attributes, you still can see the table display for these data. And finally, for the direction of filter mapping, so as a background, the filter mapping is a specification that if a filter is defined for a certain column on a join partner, that this filter should also be applied to another column of the other join partner. So if I have a filter on, let's say, the left data source on country, then I can define that if a filter is placed on country on the left source, it should also automatically be placed on the right source on, for example, also that column country or another column. So by that, you can influence how filters are applied in join nodes. And in the past, we only allowed to define bidirectional filter mappings, which meant if you had a filter on left, it was transferred to the right and the other way around. Now you have the option to define in which direction the filters should be mapped, so that you can say only filters from the left data source should be mapped to the right data source, but not the other way around. And with that, I'm finished with the presentation and would like to show you a demo, how it looks like in a database. So perhaps first about the user-defined functions. I talked about two aspects of it, the reuse of logic, as well as the pre-processing. So for the reuse of logic, let's just have a look here at the calculated columns. So we have here a country column, and we have a user-defined function extract country, and we have year, which does extract year user-defined function. And if you now look into the functions, you will see for the country, we have a substring regex expression. And if you look at it, you probably don't want to reinvent the wheel again and again for every time again, if you need it. So here you have now a way to abstract it away in a user-defined function and call it in the situations in the calculation views where you need it. Another example here is for the pre-processing, where we have a user-defined function that is used in a filter expression. So if we go here, we see here that an input parameter is taken as an input to the user-defined function, which standardizes the input parameter and then compares it to country. Why is that, for example, needed here? The idea here is that if you have here a mapping table, that you, sorry, wrong, that you map certain abbreviations to the full name, because in a database you have the full name, so you have to, if you filter, give the full name. But perhaps the user wants to enter GE for Germany or DE or D or whatever. And with using this user-defined function, you can just read from the mapping table, map it to the long name, and then do the filtering afterwards. So if I do now here data preview, I'm here in Database Explorer. You could, of course, also do the data preview in Business Application Studio directly. So if I do China, I, of course, get the data, but I can also just use an abbreviation here and just enter C point, for example. And because it's in a mapping table defined, I get still the data for China. Now, for the tabular table display, just to show it also here, I do a data preview, and now, in the analysis. And now, even if I just enter one value here, I still can show it in the tabular display, and I can also put the measures here, so I don't have to have any values on the value axis here. Then, for changing the sequence of columns, let me just open it here. I can go here to the mapping pane and then I can mark individual columns or multiple columns by keeping the control key, and then I can move them up or down depending on what I want to achieve. And finally, for the attribute aggregation, I have here now the option to define what attributes I want to use for the aggregation. I can do it in the calculated column, or also if I want here for measure, I can go here, there's a column aggregation attributes, and here I can select then individual columns or deselect the columns, and then this will be added as the aggregation attributes and written to the metadata. Now with that, I'm finished with a demo, and just to shortly point out, if you are interested in learning more about calculation views, you can join the Open SAP course. The course is still already over, but you can still read the material if you join there. And also, if you're interested in the new features in general, then you can go to this blog post, which will then be updated with the new features of QRC1. And there's also then a link to a GitHub project where you can download the example that I just showed. So if you do download it, you will get a similar structure like here. And then in addition to all the examples that I showed here, you have also an info.md file. And if you go to data preview, then you get also some explanation about the individual features and how you can make use of them. And with that, I'm finished with it. And thanks for your attention, and I hand over to Jose.
That sounds good. Thank you very much, Jan. And I'm going to just take over the screen sharing over here. Okay, so we will talk about the new features in HANA Cloud administration tooling. There's a few features that we want to highlight today. The first one has to do with self-service. There's actually a couple of self-service features that we'll point out today. And the first one is the ability for you to reset the administrator user, the password. Okay, so this applies to both the HANA database and the data lake in HANA Cloud. And more specifically, those are the administrator users that get provision when you create those instances. So DB admin for HANA Cloud and for HANA in HANA Cloud, and HDL admin for data lake in HANA Cloud. So now we have an option in the actions menu in HANA Cloud Central that will allow you to reset that user's password. This means that you will no longer need to open a ticket to reset the password. You can do it yourself. So obviously this improves the user experience and the availability of your instances in case for some reason you have been locked out of your you need to reset that user's password. Then you don't need to wait to have that done. You can do it yourself. Now, in order to accomplish this, the database user needs to have the role SAP HANA Cloud Security Administrator. So make sure that the database user has that role. Otherwise, if you don't have that role, then you will not see the reset password option in HANA Cloud Central. So this role is needed for you to see the option and then to perform the operation. And then something very important to keep in mind is that when you reset the user password for HANA database, you first have to provide a temporary password that you change the next time you log in. So that is a behavior that we have for HANA Cloud. And in fact, we give you a warning about that or some text on that in the dialog. And that's what you see on the right-hand side in the screenshot. I've highlighted that in yellow. And for data lake, there's no need to provide a temporary password. It just does it, which is also the default behavior of data lake. So there's a couple of behaviors there depending on the instance, the type of instance that you are using. But it's important to remember that when you are looking to change the password, that for the HANA database, then you change it to a temporary password. And the next time you log into the database, you get prompted to provide the password that you want to use going forward. And for data lake, there's no temp password in between. All right, the next self-service type of new feature that we want to highlight is the ability to resize the instance memory. This is related to what was said earlier in the presentation by Riti. And this allows you to either increase or decrease the amount of memory that is used in your HANA Cloud instances. Now, this applies to HANA database instances. So this will add flexibility to your organization needs depending on what you're trying to do. So it's a good way for you to have more flexible options in your deployment. It's going to affect the total capacity units that you utilize per month. So that's important to understand. We will, obviously you're using more or less capacity units, and so that is going to affect your cost. And then when you want to do this change, you can choose to apply the change with a restart of the instance or without a restart of the instance. Okay, so it's up to you how you want to do this. And one thing that we want to point out about restarting the instance is that this is actually doesn't apply only to sizing changes. It also applies when you do version upgrades and patches as well. So there is one change that is applicable to those three operations. When you select to increase your memory, then in HANA Cloud Central, in the GUI, you are going to see that it automatically increases the number of compute units, so vCPUs, and the storage amounts as well. And then when you choose to decrease or downsize the memory, then the tooling will display a new metric, which is the minimum memory requirement that gives you some information about what the lower bound of the memory is that you can bring your size down to. And it's also going to automatically decrease the amount of compute, but it's not going to decrease the amount of storage. And that is a behavior that we've done since the beginning, where as soon as you increase your storage amount, typically you don't want to decrease that to avoid data loss. Now, how does this look like? This is the changes in HANA Cloud Central that have been done. So if you look at the update mode of your instance, if you edit your instance and the settings in here, that's where you see the option of how you want to apply the changes. So whether you want to use whether you want to do a restart or without a restart. So that's where you make that change. Then a little bit on the bottom here, close to the middle of the page, that's where you see the new metric for the minimum memory requirement. So we're telling you that for your instance, what should be the minimum requirement for your memory. In this case, it's 30 gigabytes. And then you can use the controls to change the amount of memory that you want to utilize. And then you see at the bottom here some information about the new totals that you are going to have after you make the change. When you click on a save button on the bottom right, then you're going to see either a dialog, and the dialog will tell you that if you have chosen to save the changes with a restart, the instance will be restarted, then it just warns you that once the instance is restarting, it will not be available while those changes are saved. Okay, and then it asks you if you want to proceed or not. And then if you choose to update the instance without a restart, then you're not going to see a dialog. Instead, a simple toast message will display that it's going to inform you that the changes have been saved, and the changes, or the servers will now apply those changes. It'll take a few minutes. And in fact, if you go back to the instances view in HANA Cloud Central, you're actually going to see the progress of what is happening there. All right, the next feature that we want to highlight is administration of customer managed keys. So now in HANA Cloud, we allow you to use your own key management system to define the keys that you want to use to encrypt the data store in your HANA Cloud instance. And this applies both to HANA Database and Data Lake. So this enhances or strengthens the security of your HANA Cloud deployment, because now you are able to use your own keys. And so when you provision a new instance, what happens is that you have an option there to enter the KMS key ID. And that's what you see on the bottom left here on the screenshot, when you have that option to provide a key ID. Just note that once you do that and you provision your instance, you cannot change it once that process is completed. Now, the keys can be revoked. And if that happens, if you choose to do that, then the data will remain encrypted, and you will need to reactivate the key to decrypt the data. And in HANA Cloud Central, if you look at the instances table, that's a screenshot on the bottom right here, then you are going to see the status of your key is now displayed as one of the columns in the instances list. You see it here under the encryption column, where you give you the status of your key, whether it's valid or revoked. And also, if a key has been revoked, then the status of the instance on the first column here, you'll actually see a message that will tell you that that has happened, and then you can click on the on the instance name to see more information about that. In this particular example, is we have an instance where the key was revoked. All right, the last feature that we want to point out here in the administration topic is that a new session variable for workload class mapping is added. That session variable is called application source. And this variable enables you to more effectively map your workload classes, give you a more granular way to map your workload classes. We found that in certain scenarios, if you were to use the existing variables of application name and application component, they may not be accurate enough to differentiate the type of or the workload that you want to use, or differentiate between applications, just because what those variables were getting may not be totally accurate, and so you weren't able to make a distinction of when to use your workload class. So to solve that or to enhance that situation, the application source variable is now available when you create a workload class mapping, and then you can set that to equal to a specific value, or you can use wildcards as well in case you want to have that option when you are providing the application source name. And on the right-hand side here on the screen, then you see an example of what you can do when you set up the application source, and then what would happen once you create a mapping that is using the application source. And this will allow you, again, to go to a specific workload class that you've defined based on that specific variable. So just another way for you to have more control of how the workload class is going to use in your deployment. Okay, that was it for the new features in the administration topic and the tooling topic. At this point, I'm going to turn it over to my colleague, Rob, to continue the presentation.
Thanks, Jose. Okay, so for the data lake this quarter, we got a couple new features coming along or being released. First off is we're continuing to, perfect or improve the data type consistency, the semantic consistency between the SAP HANA database and the data lake relational engine in HANA Cloud. So last quarter we did VARCHAR character length semantics. This quarter we have implemented a true Boolean data type in data lake. So, historically, HANA and the relational engine are separate code lines. They were developed independently. They work really well together. And we, SAPs, invested a lot of effort over the last 10 years or so, making them work even better together. So HANA chose, when it was designed and implemented, chose to implement a Boolean data type that handles values of true, false, unknown, or null. And it actually treats unknown and null as the same thing. Right? The closest equivalent data type in the relational engine was the bit data type. So in the bit data type, natively accepts values of 1, 0, or null. So if you were to create a virtual table in HANA using the with remote clause to create a matching physical table in the data lake, this is what the SDA logic is doing underneath the covers. Is you did a create virtual table with a Boolean data type. In HANA, it would have created a physical bit data type column or field in the data lake. So what we've done for QRC1 here is we have implemented that Boolean data type in the relational engine. So you can now, in the relational engine, this code snippet on the side here, I'm connected to the relational engine directly. I can create a table using a Boolean data type. I can insert values of true, false, and unknown into that table, in addition to also still being able to insert values of 1, 0, or null. All right, and the results I'll get now if I query that table are exactly the same as what I would get querying the table from HANA. So one of the quirks is that the HANA Boolean data type, while the insert values were true or false, we'd actually would get ones and zeros back for those. The second new feature I want to highlight for the data lake this quarter is incremental refresh materialized views. So reminder, and I'm going to do a quick demo of this using that code snippet on the side here. But reminders, what a materialized view is it's a SQL view where we pre-calculate and cache the results of the view. So we materialize that result set. The benefit of that is that queries referencing the view can use that cache result set directly. They don't have to incur the cost of calculating that result set every time at runtime in real time. Right? So prior to the QRC1 release, HANA Cloud Data Lake Relational Engine supported full refresh of materialized views, meaning we had to recalculate the entire view result set anytime we refresh it. That refresh could have been manual or automatic. Right? So you could manually trigger it when you wanted to, or it can run as a background process and automatically refresh. But it had to recalculate the entire result set. So, when you're talking about the data lake, you're talking about tens of terabytes or petabyte of data, billions of records. A full refresh can be pretty expensive. With the QRC1 release, we now support incremental refresh. And again, it can be manual or automatic. So incremental refresh, huge benefit here is it requires a lot less resources to calculate just the delta or changes since the last refresh. So much more efficient. Now, I'm going to do a quick demo here. Let me just find my buttons. So let me jump to Database Explorer here. So I have that script queued up. So the first thing I'm doing is I'm just creating a table. Again, I am connected to the relational engine here. You can reference materialized views in the relational engine using virtual tables from HANA. So just like you could for any other SQL view, you can create a virtual table that refers to a view in the remote database. So I've created a table here with a primary key, column one integer, and then a status column. And to keep the example simple, what we're going to filter on is the status. So I'm going to insert 3 records here. The first 2 records have a status of open, and the third one has a status of new. All right. So my materialized view, as I said, it's a SQL view, which means that it's building a result set based on a SQL statement. So in this case, I'm selecting the 3 columns from that table 1, but I'm filtering for where the status is equal to open. Right? So when this view is built, it's only going to show 2 of the 3 records in that underlying table 1. One of the requirements for incremental refresh is that we have to have a unique index defined on the materialized view. And I actually need to define that index after I create the view. So a little bit of an extra step here. It'd be great if I could define it when creating the materialized view. But having created my view, I'm now creating a unique index on that view. Essentially, we're using this as a primary key for the view itself, right? The view being a cache result set means we are storing that data. Essentially, you can almost think of it as a temporary table, but it's persistent across restarts because it's materialized view. Having created that unique index, I can now alter the materialized view to automatically refresh, right? Auto refresh in an incremental manner. So I do that. Having just altered it, I also want to force a refresh right now. So it's got all the characteristics of the alter. That takes a couple seconds just to do that. Now, if I select from the materialized view right now, what I expect to see is 2 out of those 3 records. We had 2 records with a status of open, 1 record was a status of new. Okay, so I need to go grab, good thing I kept the script open. Now what I'm going to do is I'm going to make some changes to the table. So I'm going to insert a new record with an open status. It should show up in my view. I'm going to update one of the records, record number 3, which was new before to open. And I'm going to update record number 1 to be closed. So record number 3 should now show up in the result. Record number 1 should no longer show up in the result after this. Now, as I mentioned, the refresh is not a real-time thing. It's not like a trigger-based refresh. It is a background process. So if I go and do the select from the materialized view now, I may already see the changes, and it did. In this case, I did. It would be possible if I'd run those insert and update statements and the select statement as a single batch, I quite probably would have seen the old version of the view, right? So if you need real-time up to the millisecond results, you're not going to be working through a materialized view, right? But if you need almost up to the millisecond type of results, then materialized views can be really beneficial for you. In this particular example, we were doing a really simple filter, just on a single column, status equals open. But, extrapolate that and think about doing complex aggregations that are going to take a fairly long time to run. And then you can start seeing the true value materialized views in terms of improving your performance while doing complex calculations in the background for you. So that wraps up the materialized view automatic refresh. And again, those were the 2 features we were highlighting for the data lake today. And with that, I will pass it back to Thomas to talk about our other innovations and news.
Thank you, Robert. Wow, that was in total, I think, already a quite substantial list of innovations that we highlighted and that our colleagues demonstrated. Now, before we close our webinar with the remainder of the time, I want to talk about a few other innovations which we wrapped into the area of other innovations and news, which are still of high relevance, and therefore we believe it's absolutely important giving some updates to you, basically, so that you can take them away before we're closing the session today. So first of all, what I want to talk about is about the migration self-service support for SAP HANA Cloud. So as you know, for SAP HANA Cloud, since quite some time, we're already providing self-service migration support to migrate from the HANA services within the BTP environment to SAP HANA Cloud. And we're now super happy also to share that we can offer self-service migration support for the HANA platform on premises to SAP HANA Cloud. The scope, which will now be supported with the Q1 release of SAP HANA Cloud, will focus on the data migration first, and we will continue to enhance the offering here to also support the migration of other artifacts running on the HANA platform. So certainly we will continue our investments here, but I think this is a great first step, giving even more support to you during the migration phase when you want to move from previous versions and previous product generations of HANA to SAP HANA Cloud. For sure, you can rest assured that this communication between the on-premise platform and the HANA Cloud environment is secured by, for instance, the Cloud Connector. So certainly we try to ensure an end-to-end secure process, which helps you to trust in, let's say, this migration tool especially. So you should certainly check out the details about this specific innovation if the migration to HANA Cloud is currently the topic of highest concern for you. And we would be super happy to supporting you amongst other challenges you might be having, especially during the migration phase. Other innovations that I want to briefly touch on are related to the SAP HANA client. And first of all, I want to state that we now have support for the .NET Entity Framework as co-provider with the HANA client. We've enhanced some of the functionalities here. We will release more details about specifically these enhancements with a blog post, specifically with our What's New blog post, that we always release with the recent release of SAP HANA Cloud, and there you will find videos explaining the details. Same about the second type of innovation, which is related with the client, which is the TypeScript support that we will be introducing for Node.js applications. And last but not least, the Go driver support, which is also a big topic and a great enhancement now for our HANA clients. So certainly you should take a closer look at these innovations as well. And with that, basically, I think we can already basically conclude our webinar for today. It was, again, a true pleasure for me introducing some of the great upcoming innovations for SAP HANA Cloud that will now be introduced with our Q1 release of the product. Thank you so much for joining us, for listening to our deep dives into the innovations. As said, there is much more in the package, so certainly you should check out our resources that we will be sharing with the webinar, because there you can find all the details about all the innovations that will be introduced apart from what we've covered today. Thanks a lot to all the speakers for giving the deep dives into the specific areas, and have a great rest of your day. Talking to you soon again. Bye.